84%. So next is the docking, which will help us embark and disembark passengers from the pod outside of the station, which will again help reduce the energy required and the time, and it is more energy efficient. Next slide. One special development that we are working on is the real-life mock-up cabin, which will help people gain a real-life immersive experience, like how Hyperloop travel would look like. Like we can proudly announce that we participated in India's first global Hyperloop competition in GHC in February, and we demonstrated a pod 6.0. This year we'll also be participating in European Hyperloop Week, which will be held in Groningen, and where we plan to demonstrate a pod 8.0. So these are the sponsors. Thank you, sir. I would pass on to Hari to explain it.
Hello sir, myself Hari. So I'm part of Tutor Hyperloop. So initially I was back then in 2020 I was member of Aviskar. Then I moved to the startup Tutor. So in Tutor our aim is to actually commercialize the technologies that was developed in Aviskar and see what are the useful use cases for it and develop it. So we have segregated technology into three major parts. So initially it will start with linear induction motor. For all the applications that require 200 km per hour, we will be going ahead with only linear motor based propulsion. Then for the application that require 200 to 400, then we will be moving on to a maglev plus linear motion based technology. And then for passenger transport at the end of the day, we will be moving into a vacuum tube as well. So that's when the real Hyperloop will start. So in Aviskar, actually, when we started back in 2020, we have made two generations of linear induction motor. So starting from a 60 kilo pod to a 100 kilo pod, and now in Tutor we have developed a 150 km per hour, 1500 ton pod. So what we have done is we have modularized the motors. So if we want to add more weights, we can go up to 20 to 40 tons. We have to just add the number of motors. So we feel we are robust enough now to move to any commercial application with linear induction motors. So regarding the power electronics, we have been importing power electronics for the past 1 year, and we have got everything working, including the levitation that you saw now. But recently we have been facing some supply chain issues. So we are planning to move to an Atmanirbhar Bharat initiative where we want to develop all the power electronics. Yes, sir. Yes, sir. Thank you. Yeah. Next slide. So this is the entire E&D architecture. So the central node is our VCU, which controls everything. We have put so much effort to see whether it is redundant and safety proven. So this is the levitation technology that we have developed. So that is what we have shown you here. So as of now, we have been able to levitate all the four wheels statically. But this is where you see, while doing dynamic levitation, we are observing vibrations on the track. So we want to fix these issues, and we have to take it as a learning and improve so that we can achieve dynamic levitation in the future. So these are some of the learnings that we have had on the way. So where we are doing precise air gap control, and we want to do in-house power electronic modules, and we are also planning to make a track where it can take a loads up to 40 tons. Yeah, thank you. Next, I'll pass it on to Roshan.
Hi all, I'm Roshan. So we have in Tutor, we have developed three generations of pod. In the first generation pod, we showed linear propulsion. We took an Ashok Leyland dose chassis and then modified it for our use cases. But then we faced a lot of issues when we took some other chassis design for some other purpose. So we made a ground up design and we created one chassis for on our own. So this is Gen 1 is the chassis which we decided on our own. It is a skateboard chassis which brings the CG down. So during dynamic levitation, we'll have less load transfer. And we have now done Gen 2 pod in which you saw the levitation over there. So here it will have vacuum operation along with magnetic levitation. So for us, we have all the subsystems are designed for full scale. So they will act as a payload. And then we have made it modular so that in case if you have to replace some other part, it's just easy. We just to remove the bolt and then add it from the bottom. And we have brought the floor very down so that CG height is very less. And we have a top hat. So when during non-vacuum applications, in order to reduce drag, we use a top hat. So we got inspired by Falcon. There's also Indian name for a Falcon called Garuda. That's why we named our pod Garuda Vahan. And we had help from ANSYS in doing simulations. And we were able to reduce the drag up to a very good amount. And then we took Ashok Leyland's design studio help to come up with the front fascia for our top hat. And also with Katya's help in bringing the shape. And we are currently having steel wheels and solid rubber tires in order to have lesser deflection during full load. And initially we had a pneumatic brake, now we have gone with an electric brake. So this is a second redundant brake. First one would be from the motor. In case if that fails, then we'll go with friction brakes. And we also have guides, which are a passive form of lateral control. We are now working on a lateral EM. We are also making the pod compatible for operation in vacuum. So this is a press chamber which we have made with the help of E-plane. And this is the 8.6 meter tube which we have in IIT Madras. So we'll first test a pressure chamber in this, do static testing here, and then only for dynamic testing we'll come to the 410 meter pod. We had lot of learnings from this journey of more than 2 years. So we had track vibrations. So we used the TMD to reduce the track vibration, which was successful in reducing the amplitude, but still it was not up to the level we want, control system wanted. So we are actually finding ways in which we can reduce the amplitude more. And the pressure chamber currently is having small leaks, which we will plug in the few weeks, and then we'll be able to show its operation.
Hello, good afternoon. I'm Karthik here. I handle the digital twin vertical for the Tutor Hyperloop. So as the name indicates, digital twin is a virtual copy of any physical object with all its CAD designs and thermal and all the physical characteristics, parameters, along with the live data feed from all the sensors when it operates. So why is this important is because for any critical infrastructure, important infrastructure, right, smart buildings or cities and transport operations, using the concept of digital twin, we'll be able to optimize the capacity, optimize the operational cost, improve the safety, improve the customer experience, and improve the lessen the time needed to actually bring out further improved versions of the objects. Yeah. So what we have done is, like we have optimized the pod architecture to levitation, linear propulsion, and the vacuum, we have actually optimized the architecture for digital twin also, so that for any real world problem that the railways has or any other transport system has, we will actually deploy only the respective So depending on the use case, we will deploy the level of architecture that is actually needed. Yeah. So based on the, we have got some good support from ANSYS and DASO here. Using their support, we have actually built a mini digital twin application. We have taken a sample, cargo pod operation from Chennai port to Madurai, inland terminal, and we have actually demonstrated how a pod can actually take cargo and then take it to the inland terminal with various, real-time monitoring of these systems. And this uses real CAD model and thermal and physical analysis of the battery system that we are actually using in the pod. So this is, yeah. So moving on. So we have also been in parallel interacting with a lot of railway officials and doing our own secondary research. We have identified certain important use cases that we could actually solve using digital twin for the railways. So some of these we have listed here. We would be very happy to actually use the services of Shri Pankaj Sharma and then talk to them and actually identify specific use cases and take it up for resolution. This is kind of the timeline that we have actually got involved in this digital twin. We have submitted proposals and had reviews with Shri Pankaj Sharma and team. He has been pretty supportive. What we would like to do is actually get the twin proposal approved and then probably take up a specific problem for solving it. Okay. And this is the VR demo that we actually had. You actually saw the journey and those things. Thank you.
Good afternoon, sir. So you saw all IITians. I am a product of Indian Railways, alumni of the founding batch of Gati Shakti Vishwavidyalaya. So here, why we are different from others? So everyone's heard Virgin has failed, other Hyperloop companies has failed. What makes us different? Our initial focus is on cargo, area where the government is focusing a lot. We did the technology modularization like our colleagues talked. We did linear propulsion, maglev and vacuum, which gives us users for each case within India, ports, airports. I'll talk about it in the next slide. We have scalable infrastructures. Like you saw outside the tube, we can use the same infrastructure for linear propulsion, maglev, and the same infrastructure for vacuum. Not necessarily we need the tube for doing the first two technologies, but once we have to go above 600, we take the tube. Now, this is one of a very unique approach, consortium approach. We thought we don't want to do this alone. We are taking all academia, industry, government together with us. We have ANSYS, Dassault, L&T, and railways. Customer-inspired application, I'll talk about in the next one. Frugal engineering, this is one of the top applications that we have advantages in India. So this is our aim to achieve a full stack passenger technology stack by end of next year. This is the consortium approach that we are planning to take with industry partners, academia, and the government. Next. So these are some of the projects which we are going to launch soon as for our commercial aim. Railway board, PED sir has been very supportive in this aim. By next month we plan to launch Kolkata Metro, Nilgiri Mountains Railway project. Container Corporation of India has been kind enough to give us one whole yard to automate that, and digital twin. These are some of the other potential cases we are in discussion with. Can we go on the next slide? Okay, so DFCCIL writes, all railway PSUs have been kind enough to invite us and give their whole backyard to do whatever we want to do. Again, coming to the state government. So this is an ask that we want from you, sir. IIT director has been kind enough to give an in-principle approval to create a track around the tube, like 1 kilometer loop. We interacted with army. We interacted with all potential transportation holders, and we found out this can be a base that we can make it in India and make it for the world. So we would love if you would support us in this project to make a whole loop around the tube. So that is all from my end. Thank you.
We at the E-Plane company are designing India's first flying air taxi led by Professor Satya Chakravarti. This is supposed to commercialize by December 2026. This eVTOL that you're seeing here is our flagship product called the E200X. It can carry 3 packs, that is 1 pilot and 2 passengers, and can cover a total range of 110 kilometers in a single charge. Slide. So this aircraft has various use cases from passenger to cargo. Our very first go-to-market use case is that of an air ambulance. We have an order book of 788 air ambulances, 1 for each district in India from this organization called ICAT. Here are the key use cases for the Indian Railways: disaster response, rapid medical evacuation, air ambulance, remote area maintenance, crew transportation, and delivery of critical spares or tools. Next one. Okay, so at E-Plane, each aircraft is designed with utmost safety in mind. In case of failure, the aircraft is built with 5 levels of redundancies. Next slide. We are currently in the process of building our very first prototype. As far as the regulatory landscape in India is concerned, we are working very closely with the DGCA, who are carving out the rules very well when it comes to vertiport standards, certification, and operation of the aircraft. Thank you.
Hi sir, my name is Vaishnaw. My colleague earlier spoke to you about the eVTOLs, right, which is the manned aircraft. So way before we actually started designing the aircraft, we built lift and cruise vehicles here for our own tests, right? So these are what we today call drones. So some of these vehicles that we built in the past, we have a lot of applications built on them to, sort of push edge computing to industrial use cases, right? We were earlier looking at combining RGB plus IR streams and pushing analytics to the edge, sir. Now, industrial use cases were for inspection and surveillance. We want to bring this capability to the railways. We worked with the RDSO and the southern headquarters to now come up with about 9 use cases. Can we go to the next slide? These are the 9 use cases that we picked up specifically for the overhead equipment inspection, right? So we're looking at the traction lines and looking at these specific 9 use cases. I'll talk to you a little bit about them in detail in the next slides. We are now using a small vehicle called the multicopter to do data acquisition, but we will move to a bigger aircraft, which is a fixed wing hybrid, which you will see a demo of outside when we leave, right? The camera that we are packing in this has a dual sensor, which means we do RGB plus IR in the same camera, so the point of focus continues remaining the same. Next slide. We sort of broke this problem down. We did problem definition. That's what we did with the railways, which means we spent a lot of time with the section here at the Egmore yard. We then looked at all the 9 use cases, classified sub-faults in those 9 use cases, then did a manual inspection of how does the railways today solve for it, looked for the gaps, and then came up with how can a drone sort of work in this scenario. And then we spent a lot of time with RDSO in Lucknow, and we started doing a lot of data acquisition. So we continued spending a lot of time. So this is an actual OHC inspection card that I was a part of, where we went and looked at how the maintenance happens today, and how can we use a drone to sort of automate the whole process. And with this understanding, we then went into the data acquisition phase, where this is the specific case of a 9-ton insulator. We started looking for specific issues like flash insulator, broken insulator, and under insulator at multiple categories, right? So we looked at individual faults and how to acquire data for that. Next one, Karthik. These are, again, a zoomed in image of where the insulator faults are and how we're looking for them. We took this data, we then labeled them, then started training our models on top of this data, right? Next slide. And again, there were other use cases, so we started collecting samples for cantilever health, missing number plates, dropper issues, etc., right? This is an image of our drone fly at the Egmore yard here. Again, thanks to Southern Railways for allowing us to doing this. And you can see a video of where the locomotive is moving and we're looking at a turnout. Turnout inspection is super critical because you have two wires coming on top and the gap between them is 50 mm. So you continue maintaining 50 mm, that's what we're trying to gather. Next slide. Yeah, that video was from the drone itself. This is a sample of the model that we've run. We started already being able to detect bird nests on top of mass, right? And also we started looking for the temperature rise in the OHE components. These two are models that are built. We're now scaling this up, Karthik, next slide, to include assets of the track and signaling, right? There are 22 use cases that are now being discussed. We're now figuring out a point of view and we're now going to the next MOU to sort of put this in place. Thank you. Next slide. Thank you so much for your time, sir. Really appreciate it.
We now request Honorable Minister of Railways to come and give a talk.
வணக்கம். எப்படி இருக்கீங்க? நல்லா இருக்கேன். சூப்பர், ரொம்ப நல்லா இருக்கேன். This place is full of so much energy that I just can't describe it. I am so happy to see the young, energetic engineers working on this new technology, getting such new experiments, and we are just small little help that we are doing. I think this will really lead us to some very good solutions for the country, for our people, and for the startups, and also for the world of technology. Whatever support is needed, Professor Kamagoti Saab, Professor Chakravarti, I am just a message away. I am 72nd member of the team, right? So, anytime, anything, whatever you need, just I am a phone call away, message away. Let's make it a success. Let's be very focused on the quality, focused on safety, focused on how do we scale up this entire experiment once we do the prototypes and everything. So keep that ultimate goal in mind. Try to be as much out of the lab as you can, so that the lab environment is very safe environment, right? But the outside environment will really test us in a big way. So to my young friends, try to be as much outside the lab. They are laughing. Probably the professor wants them to be more in the lab. So try to be as much outside the lab and in the field, and look at industrial processes. Go out, see some factories, see how they manufacture the things. And I'll request General Manager ICF and General Manager Southern to fully support this entire initiative. Thank you so much for your support, and thank you Railway Board for your support. This is really shaping up well. And Anna, I'll request you to come one of these days whenever you can find time and encourage this team. They'll all be enthused by your energy. One of the finest energetic of, come. Finest energetic leaders that we have. Come, brother. See, so much energy he has. So you must really get the benefit of his energy. He's very energetic leader. So, and a good, dynamic, future-looking. He's looking at the future of Tamil Nadu. So look at that. Make sure that you get the benefit of his leadership. Thank you, friends. Thank you.